Welcome to the video on proof by mathematical induction. In this video, we're going to do an example of how we prove that a series equals a particular sum. But before we get to the example, let's talk about the four main parts or four main steps to an induction proof. The first step is called the base case. And the base case shows that the statement you're trying to prove holds true for the first or the lowest case possible. So we call that P of 1. The second step is called the induction hypothesis. This step, we assume that the statement we're trying to prove holds true for some value where that value is between the base case and the value that we're trying to prove it for. The third step is called the induction step. That's where the magic happens. This is where we apply the induction hypothesis to show that the statement holds true for one beyond that assumption. We're going to call that K plus 1. When you put all of those together, that's mathematical induction. And you're going to think back to the domino example. If the K plus 1 domino fell, then the K domino had to fall before that. So if we can put all those steps together, we wind up with our conclusion, where we're going to conclude that the statement holds true for all natural numbers. All right, on to our example. We are going to prove that the series 1 plus 3 plus 5 plus all the way up to the nth term of that sequence, which would be 2n minus 1, is going to equal n squared for all natural numbers. That's what the n is an element of the natural numbers means. So to begin, I've written the proof again. Don't feel like you have to write that out for a second time. I'm just going to keep that at the top of every page where we're doing the proof. We want to actually write down base case. And we're going to show that this works when n equals 1. Okay, and we're going to write that kind of a paragraph form. When n equals 1, the left side of this statement, and instead of writing this entire statement, let's just say like the statement is called star. Give it a name. The left side of star would just be 1, meaning it's just this first term. And the right side of the statement, star, would be, now we're going to go into the right side, 1 squared, which is 1. They match. That's exactly what we want to happen if the statement is actually true. So, star holds true for n equals 1. We've just established that this works for the base case. Now on to our induction hypothesis. We are going to suppose that this statement actually does work up until a certain point. So we'll do 1 plus 3 plus 5 plus dot, dot, dot. And where we're stopping is somewhere in that dot, dot, dot. We're going to call that the kth term. So we're going to stop at 2k minus 1. That would be if you stopped at the kth term. We're going to suppose that this statement works. So that would equal k squared. There are a few stipulations. This only works for a k that is a natural number, and it only works that if it's in between 1 and n. Now on to our induction step. The induction step, we want to show that this is going to work for k plus 1, meaning that when we use this sum over here, that k plus 1 squared would be the answer. So our goal is to show that we wind up with a k plus 1 squared. All right, so then 1 plus 3 plus 5 plus dot 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 to the kth term plus the next term, which would be, if we plugged in k plus 1 for a term, that's going to have to equal what we said the first through kth term add up to. We said that in the previous step that they add up to k squared plus our next term. And the reason that we say that is by the induction hypothesis. So basically, we just did a little substitution from the previous step. Now we're going to simplify. So this becomes k squared plus 2k plus 2 minus 1. And then that becomes k squared, plus 2k plus 1. And remember how we said that we wanted to get a k plus 1 squared? Well, this factors into a k plus 1 squared. So that's really good news for us. Thus, the statement star holds true for n equals k plus 1. So we did it. That was actually the magic. We've made everything come together. So our conclusion is that by mathematical induction, star holds true for all natural numbers. And that is your first induction proof. Good luck with the rest.